We have only one thing to do for this before we actually have pretty much parity with my example project that you saw at the very beginning of the entire series, and that is experience. So let's go over that really quickly. We can open up our enemy actor and give it a new variable, and that will be something like XP on death. We'll make that an integer, and by default I will give that like 10 experience per kill that we do. Now, awarding experience is again one of those things which, whatever your game might want to do, it might be different from what we're about to do here. I'm going to do what I would presume is one of the more complex way of doing it, and then you can figure out what you want to do based off of that. So what we are going to do is we're going to keep track of which of our party members were alive at the time that an enemy died, and then only if they're also alive at the end of the battle do we award the experience. So you can just award the experience right off the bat in the moment when a character dies to everything that's alive. You can keep track of how much experience has been built up throughout the battle and award that to any alive members at the end of the battle. I'm going to do both. Every individual character going to track how much experience they have built up throughout the battle, and only if they're alive by the end will they actually gain it. So, back in the battle scene, we will go make a variable for that, and that will be the XP to reward. And we'll make this a type actor, because we're going to be tracking it per actor, obviously. And then we'll turn it into a map with, so we're going to say, hey, this actor goes with this amount of experience, and then we can just use that to actually award the experience. Now, when an enemy dies, we need to do some stuff. So let's go ahead and open the event graph. We already are in the event graph apparently, and go to where the enemies die, which is right over here. The enemy party for each loop, we bind to enemy killed. Now we do all this. We also want to do some stuff about how much experience it is going to give us. So for this, I'm just going to cast to enemy actor, and we do all this before we destroy the actor, by the way, because we need to actually access information on the actor. Technically, destroying doesn't happen until the next tick, I believe, so it would be safe to do it after, but it's just good practice to do stuff with an object before you destroy it, because otherwise it's going to be very messy. And we'll call that something like add XP to award. This will be a input that will be the experience that we need to award, and that's of course going to be a integer. And then what we do is we take our player controller, of course, we get the active party at this time, we for each loop over it, and we get the turn-based component and then get the current value of an attribute. You can guess where we're going with this. We're going to be checking whether or not these guys have more than 0 HP. So if their HP is greater than 0, we'll move on and actually award their experience, or at least store the experience that we need to award them at a later date. So we're going to make a local variable and call that a previous value, and that will just be a integer and not be a map or something. It's just going to be a singular integer. If it already exists, we can use this finding node to set the value of what it already had accumulated as far as experience goes to whatever it has found from this map. If it hasn't found anything from the map, that means that it doesn't exist yet, and we need to like kind of initialize that value at being 0. So then what we do is we take our map again and we simply add to it. The wonderful thing about maps is that if you add something with a key, that is the value on the left, in this case the actor, that already has that key, it's just going to update that entry. It's not going to make a duplicate or anything, it'll just update that entry. But if it doesn't yet exist, it will make a new entry for it. It's actually quite nice. So what we'll do is we'll add the previous value that we had, so that's either going to be what we found or going to be 0, and we're going to be adding to that the experience that we give in to the parameter of this function. And in either case, we're going to hook up both of these to that adding node. We just take care of the 3 party members that we have on the screen at the time, and anytime something dies, we add to that for them in this map. So then all we need to do is go ahead and actually put in that XP to award function in here. So after we cast to BP enemy actor. But before we destroy it, we're just going to run this function. And now we just need to make a corresponding function at the very end of the battle that is going to award the experience that we have counted up. So for that, I'm just going to call that function award experience. So award XP. And that's going to get this map. We'll get the keys from this map. So that's all the actors, so that we can for each loop over there. If nothing else, after this entire series, you should be intimately familiar with for each loops. And then for each one of those, we're going to try to find them in this map again, because it's going to find the corresponding amount of experience that they should be awarded. But we'll only really do that if a couple of things are true. Here, we're going to actually cast to the player actor as well, because we're going to set up all of the experience gaining stuff and the leveling up stuff that goes with it in the player pawn, because the enemy pawns obviously don't need to be able to like gain experience. So here we do actually cast to the BP player actor for once. We double check whether or not it was found in this map, because if it was not, for whatever reason, it should be, because we're getting the keys from this map, but never hurts to put in an extra like little bit of defense there. We get the turn-based component, and we again check if its current HP is below 0 or not, or rather if it is greater than 0. Because if it is, what we'll do is we will award the experience. And for that, we will make a function on the player itself. Because what that's going to do is it's going to increase the experience on that player character. And then also immediately, if it has gone past a certain amount of experience, level it up and apply some stat increases and the like. So let's open up our player actor blueprint and create a function to match this. So we'll give experience. The experience to give will be a input. So we'll just make that XP, will be an integer, and we'll make an experience variable on this thing as well. So total experience. And we'll set that to being its like current value plus whatever we give into here as well. And this is the giving of experience. It's quite as easy as that. Now let's look into a like experience curve and level ups. Because for that, we can just create a curve, and that'll be a curve asset like this. We'll make a curve float, and we'll call this the level curve. You might want to make a level curve per character or whatever. We're just going to do this one. There'll be assets that you can just swap out what asset you're using with different child blueprints off of this BP player actor. Again, if you have like 5 different characters in your game, you're going to make a separate child blueprint off of this for each one of those, and they can have their own references to their own assets for their experience curves. For this experience curve though, what we're going to do is I'm going to add a key, and then I'm going to click on that key. Coming up here, we can see this is the amount of experience, and this will be the level that we'll be at. So we at 0 experience want to be at a level 1. And that will kind of make it move around a little bit. Don't use middle mouse here, by the way, because middle mouse actually switches the position of our key. To navigate this interface, you want to use right mouse button. If you press middle mouse button just on the line, it creates a new key for you. And on that one, I'm just going to see what I had in my reference project. I said about 50,000 experience would be level 99. So let's say 50, 1, 2, 3 zeros, and that will be level 99. Now, this is kind of unreasonable to try to like figure out what this looks like, because it's effectively just a flat line. So what you can do is you can just come up in here and set absolute view. That'll kind of scale the X and the Y axis to the point where it is just like screen filling. Then selecting both, which you can also just do by Control A. I'm going to make both of these cubic interpolation, and then I'm going to toggle the weighted tangents. And then we can actually make the XP curve as steep as we want. So what you might be used to seeing a lot is an exponential curve that goes like slow, 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 and then like ramps up like this. But since we're giving in the experience and getting back the level, we actually wanted to look the other way around. We wanted to have a very steep incline at first, and then become more flatter toward the end. Because, again, what you're maybe used to seeing online for other level curves is generally the level and then how much experience you need for it. This is how much experience you have and what level that gains you. So it's the same curve, just from a different perspective. So here we can see, especially if we like start zooming in a little bit again, at level 0 or level 1, we have 0 experience. If you want to get to level 5, that's going to be about 270 experience needed. But then, if we go over here and we look at, well, we're about level 98 here. Let's go to, like, we're 98 to start. You can see that it takes a while to get there. Level 98, you're about 35,000 experience, 34,000 experience. And it takes another 15,000 experience then to get to level 99. So that is the curve that we have here. The wonderful thing about this being a curve is that you don't need to like put in a bunch of individual numbers, and you can fairly easily just kind of play with how this curve like flattens out toward the end and what it kind of feels like from a gameplay perspective. So we have an experience curve now. Fantastic. Let's actually put that into practice. So going back into our player actor here, after we've given some experience, let's make a variable. That'll be our XP curve. That'll be of type curve, and then we can find in the object references, so that's down here, those gray or like skin colored ones, we want a curve float object reference. Probably want this to be instance editable because we're going to be editing this based on different characters most likely in a real game, and we can just set this level curve to be the default. Now we can pull that into the event graph here for this function, and then we can get a float value out of it. And that's going to take in a time. The time is the x-axis here, so that's left to right. And it's going to return you the corresponding y value. So after we set our new total XP, we just give that into get float value. And then we simply check if we floor that value, is it then greater than our current level? And you might be thinking, we don't have a current level. That's what we're going to be adding next. So we add a new variable here for our current level. So let's say level. We can just start that at 0. That's not that big a deal. But let's start it at 1 nonetheless. So if that experience gain got us to an amount of experience where we have passed the next level threshold, it's going to round down to that next level. So let's say we're level 5. And we've got experience and we're now level 5.9. Great, that's still going to round down to level 5. But if we are just over that threshold, we're now at level like 6.00001. That means that this floor node now rounds that down to 6, which is greater than the 5 that we were at before. So this is now going to return true. And we'll put in a branch there because that's going to then level us up to the corresponding level, which will be a separate function to its own. So we'll set our new level. Let's set level up. And then the input for that will be our new level. The first and most important thing obviously being to set our level variable to that new level so that we can be proud of the experience that we've gained. And then we're going to just make some more curves for our stat upgrades. I'm just going to do it for HP for now, but in your own game, obviously, you would also do this for like your strength and your defense, or maybe like your mana, or any stat that you want to upgrade, your speed. You would make essentially the same thing that we're going to do here for HP for any stat that you want to upgrade. So we'll make a curve for that as well. So let's do HP curve as a variable, which will also be a curve float object reference. Again, probably make this instance editable because every single one of your characters is going to probably have its own set of these curves. And here we're going to, once again, just get the float value that corresponds to whatever exact level we are at the moment. Now, you could also do this with data tables, granted. I like doing it with curves because you'll see why in a moment. But after that, we can just get our ability component and apply effect to self. And in this case, we're going to be applying the HP. We'll set our effect math to override whatever comes out of here. And we'll, of course, set our maximum value with this, because that is what HP upgrades do. They set your maximum value. And when we hook that up, the only thing now that we need to do is make an HP curve. So let's make an HP curve. We can just, again, make a curve assets. So curve, float curve. Call this HP curve. Maybe organize your project a little bit better than this. And let's make a really weird HP curve, okay? Because I feel like it, honestly. We're going to add the first key, which is going to be at level 1. We're going to have a certain amount of HP. So let's say we have like 500 HP at level 1. That's going to make us scroll quite far out until we have found that. And then let's say that at level 99, so here we're kind of doing the opposite of what we were doing before, right? Before, what we were doing is we were giving in the XP and getting the level. Now we are giving in the level and getting the like stats total that this stat is going to get us. But at level 99, let's say that we have about 2500 HP. We can go back in here, set absolute view, so that we have a more representative view of how this entire thing goes. Now, what we can do is we can just add a random key. Everything will be linearly interpreted anyway. But we can say, well, actually, I want to say at level 2, I am going to get a 600 HP. So I have a 100 HP increase from level 1 to level 2. Then at level 3, I want to go back down to 400 HP. I don't know why you would want to do this, but this is something that you can do. And then until level 10, I want to stay at 400 HP. Then at level 11, I suddenly want to go up to 1000 HP. 1000, not 100. And you can start making these like really weird curves that you can like very custom make to what you want to do. And if you want to just linearly or even cubically interpolate between two of these keys, you also can just do that. You can just say, okay, actually up until about level 25, I'm kind of good with this like linear growth. So we can find level 25 on this. And then let's find like level 25 that we want to make. We can find that right about here. That can just keep being linear. And then at level 26, let's make another one. Level 26 to level 35. So let's do up to 35. We want to stay at the same amount of HP again. So that will be 1250 in this case. This is the weirdest stat curve that I've ever seen in a game, but you can do a lot with this. And the neat thing is I can just select these two and move them like together, and they will snap to this grid as well, which is quite nice. But it's much more easily adjustable than making an entire data table where you manually have to fill out every single level's stats, which is very tedious and lots more work. So this is our HP curve now. Let's check in our level curve actually what level 2 will require for us. So we actually need like 120 experience to get to level 2. So let's actually go back into our enemy actor and XP on death, just set that to like 60 so that I can be sure that I get to level 2 over just one battle. And then in our player actor, what I'm going to do is I'm going to print out a couple of things in event tick. So we'll get our ability system components, which we'll use to get currents for HP. Well, actually, we want to get the max for HP, don't we? So get max for the HP. And we'll print that as well as the level. So we'll do a append node. We'll get our total experience. So write that out, experience. Then get the experience. Then next up, get the level. Pull that in. And then lastly, we also get the HP. And put that in as well. Of course, we do need to actually hook this up into the execution flow. Otherwise, that's not going to work. I guess these could be pure functions now that I think about it. There's no reason for them not to be, because they're just getting values anyway. So that would probably make a lot of places a little bit easier to work with in the project. I'll leave it up to you to fix that if you can. Now, it's also probably a good idea now that we have this to just, on begin play, set our level by default to 1 this way. So that way it will actually apply the stats that are corresponding to level 1. And make sure that this HP curve actually has a curve selected into it as well. And now, if you want to be able to save your levels and stuff like that, because we're applying all of those stats based on a curve, based on purely experience, the only thing that you actually need to store in your save file is the amount of experience that your character got. Then when you load your file, you just give them that amount of experience through the give XP function. And then it'll automatically set them to the proper level. And when they are the proper level, using those curves, it'll automatically set everything to the proper amount of their stats as well. So you don't need to go ahead and store like your HP and your strength and your whatever. Just store the experience and you'll be good to go. Anyway, we can see that I have 0 XP at level 1, means I have 500 HP. So that actually makes sense. It looks like I have almost no HP at all because obviously my current HP is like 50 and I have 500 actual like max HP. But if I kill this thing, nothing quite happens yet. If I kill the other thing as well, it doesn't yet give me the experience. I probably messed up somewhere along the lines, and that is that I didn't actually use the give experience. Whoops. So yeah, in award experience, in our battle scene, we actually do need to then go back in at the BP player actor and give XP, the function that we made specifically to give XP. And then going back into the event graph, of course, at end battle, somewhere in here, you also put in the award experience. So I'm going to just do that quite near the beginning here after stop battle. We award the actual experience. And then in the give experience, at the very end here, if that new level is higher than our current level, then we actually level up to whatever that new level will be. This will also allow you to level up more than one level at a time because it's just setting your level to whatever new level you give in. So with that, now we can do a battle and I can just kind of like race through this. It should give me 180 experience for these 3 enemies in total at the end of the battle. And then we level up to level 2 and we have 600 HP now max, and we're kind of lagging out because I'm printing so many things. We have one more thing here, remove item. It's trying to remove things from an active effect, which is a little bit weird because this thing is trying to remove itself from a target component that no longer exists. So what we can just do is we can check is valid. Well, we can just actually convert this to a validated get, to be honest. And then just holding control, we can move this over here, and only if this is valid do we try to remove it. The only reason that we need to remove this to begin with is so that Unreal doesn't have like a reference to it existing anywhere else in another actor and keeping this thing around. But if the like owning component has been destroyed to begin with, there's no reason to remove this, and Unreal will just clean itself up with that. So we should be able to see that if we go through this super quickly now, and we then end the battle. Only have some errors to do with trying to spawn in particle systems at locations where things are about to die anyway. So you ideally would probably apply this effect after spawning in the particle system, because otherwise it won't be able to get the actor's location. This is all like minor cleanup for the specific ability that I made here to showcase. So don't worry too much about all of that. But now we have a functional turn-based RPG. So congratulations, here we are. I'm going to make one more video, and in that video, which is going to be a little bit more unscripted because I didn't actually like prepare for that, we're going to set up the AIs to be a little bit more intelligent to prevent them from targeting things with 0 HP, but still weigh them toward attacking things with lower HP, so that they weigh toward attacking things that are almost dead, which is a good strategical thing to do, but still with a little bit of randomness in it so that they're not too determinate. Making a full-fledged JRPG style anime AI is going to be a little bit beyond what that video is going to show. We're just going to kind of set up the beginnings of that with a state tree. And a very big thank you to all my Patreons. You can see them on screen right now. If you want to help support the channel or get any of the project files in any of my tutorials, there's a link down below to the Patreon page to support me, or alternatively as a YouTube member. And a huge thank you to my Cave Big Brain tier supporters, which care more for coding than impulse control: Earl, Monserville Erno, my Cave Students tier supporters, Paul Berry and Oiku, and my Cave Digger tier supporters, Mauricio Farias.